some reason there's this massive deal about why everyone in the nation hates fractions, and I have no idea why. And the first thing to do with fractions is simplifying them. So for example, we know that mathematicians like to keep things really neat. So if I looked at that, yes, it's a fraction, but I can make it into a different fraction, which means the exact same thing that it's equal to. So I notice that there's a number that goes into both of these. It's a factor of both of them, and it's 3. So if I divide each one by this common factor 3, I get 2 thirds. So that is the same fraction, but it's simplified down. We've got smaller numbers, and it's much neater, and that's the way the mathematicians write stuff, and the way that you'll be expected to simplify things in the exam. Let's look at another example. 24 30. Okay, so I noticed that both of these can be divided by 2. So 24 divided by 2. Okay, and I don't stop there because we can keep going, and these are both divisible by 3. So we have 12 divided by 3, which is 4, and 15 divided by 3, which is 5. And here we go, that's our final answer. So that's simplifying, often asked to do it at end of questions and stuff like that. So multiplying, this is honestly just super nice. So if I have two fractions, 5 over 7, 4 over 5, multiply together, all I do is I multiply the top and I multiply the bottom. So 5 times 4 is 20, put that on the top. 7 times 5 is 35. That is all you do, multiply the top, multiply the bottom. Multiplication in fractions is just so obvious and just nice to do. But however, we've just talked about simplifying, and I noticed this can go further. Both can be divided by 5. So I get 4 over 7. Simplified version, same fraction, just simplified. Okay, so multiplying, so easy that we're going to use it. Dividing. So dividing fractions. This one is, I'm just going to use the same number, so 5 over 7 divided by 4 over 5. Now what you do, there's just one extra step to multiplying, and you turn it upside down again. Upside down, I'm gonna turn. Every time upside down comes up, I'm gonna sing that song. So you turn it upside down, and then you go back to step 1, which is multiply. So it's just one extra step to multiplying in dividing fractions. So we have 5 over 7, and instead of divide, this is now going to become a multiplication because we've turned this one upside down. So we've swapped 5 over 4. Multiply that through. 5 times 5 is 25. 7 times 4 is 28. Okay, so that's multiplying fractions, and that is dividing fractions. Okay, so a mixed number and improper fractions. So a mixed number, for example, is something like this. 1 and 2/3, and it mixed because it has a whole part, an integer part, and also a fractional part. And an improper fraction is, I'm just going to write an example on the side, 55 over 34, something that has its top bigger than its bottom. So you might not have noticed, but normally all the fractions you look at, the top is always less than the bottom, but an improper one is one where the numerator, that's the word, that's the good terminology we're looking for, is bigger than a denominator. We don't like these, we try and convert them this way, but we're just going to practice converting them each way. So we want this mixed number to turn into an improper fraction or a top-heavy fraction. We have this, 1 and 2/3. Now if I was going to visualise this, I might think of like a chocolate bar or something. So I have one chocolate bar, which would be this, and I have 2/3 of a chocolate bar. So where I would think of that in all these little third segments, so if I look at this 1, I've technically got 3, 1, 2, 3 of the thirds. And here I've got 2 of the thirds. So if we're going this way, I have 1, 2, 3 of the thirds, and 2 of the thirds. Okay, and another way to think, you know that 3 over 3 as a fraction is 1 because they can cancel to be 1, so we know that's correct. So we just kind of add them, but we put this, the whole number, into parts with the denominator. And because these two are the same, we can just add the numbers. So if we add 2 is 5 over 3, and that's the improper fraction. What if we have an improper fraction? So let's go 40 divided by 6. So improper fraction, top heavy fraction, numerator bigger than the denominator, and I want to go this way. All I do is I do this calculation, so I do 40 divided by 6, and I know the answer is 6 remainder 4, because it doesn't go in exactly, hence it is a fraction. So I know the answer to this, just doing this calculation, is 6 remainder 4, and therefore I take the 6, so I have 6, and I take this remainder, 4 up here, and I have 4 of the 6 left over. Fraction of something. So of in maths means multiply. So this is the English word of, and the maths translation is multiply. So now we're bilingual, almost. This is a very, very useful fact in things like probability as well. So, for example, a fraction of an amount just means multiply. So let's say I'm driving to school. There I am. And this is my petrol tank. And on my journey to school, I use about this much of my, I'm going to call that 2/11 of my petrol tank. And I filled this petrol tank up yesterday, and to fill this whole tank up, it cost me £50. Okay, so how much money have I spent on fuel with just that one trip to school? So, the way to think of this is in Englishy terms using of. So I've used 2/11 of my tank. And my tank costs £50, so I've used 2/11 of £50. And because I've said the word of, alarm bells going, sirens ringing, that means multiply in maths. So 2/11 times 50, which is 100 over 11 pounds. Okay, so when reading a wordy question, I would advise you literally write out the key bits of information that it does tell you, just bullet point them. Okay, so it's asking us how many pupils like sport. So what fraction of 1,200 pupils actually like sport? So we've been told there's this many girls and this many like sport. So when I'm reading this, I see 2/5 of girls like sport. Oh, that's not very good, is it? 2/5 of girls like sport. That of, alarm bells is multiply. So 2/5 of girls. So 2/5 of girls. That's what I'm interested in. But that is 2/5 of multiply. And girls, we have 575 girls. So that's the number of girls that like sports. Okay, but we don't have a school of just girls because we've got some boys in there. So how many boys are there? If there's this many girls, there's 1,200, must be 625 boys in total. And we're told that not all of those boys like sport. Okay, we've got this of again. So now we do 3/5 of boys, 625, so, I'm going to have to put that into my calculator again. 375 boys like sport. So we've got this many girls liking sport and this many boys liking sport. Question is, how many pupils like sport in total? So 230 plus 375. So 605 pupils like sport. You might want to write that at the end, but clearly I don't have too much room there. Okay, so here we go. I've got a fraction and then I've followed by of. Alarm bells ringing, of means multiply in maths. So I've got 3/5 of the bottle, so I've got 3/5 of the bottle, which is 1,000 millilitres. So that's 3/5 of, multiply, 1,000. That is 600 millilitres, so that's how much I've drunk. Another example. How much of the triangle is shaded? Okay, so first we're going to break it down into this triangle and this triangle. So how many parts do I have? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4 of them are shaded in. So 4 out of 6 is shaded. But it's not 4 out of 6 of my total thing, it's 4 out of 6 of half of my shape. Half of my shape. Okay, and we know multiplication, you just multiply through 4 over 12, and we can simplify that to 1 over 3 if we divide each by 4. Okay, in triangle 2, here I have 1 part of my 3 parts shaded. I have 1/3 of this triangle shaded, but as we know, this triangle is only half of my overall shape, so it's 1/3 of half of my shape, multiply through, so that's 1/6. So then in total, shaded, so we have 1/3 part shaded plus 1/6. And we need to get a common denominator here. We'll go on to adding fractions in a minute. And that would be 6, 2 plus 1, 6, which equals 3 over 6, which is a half. So in total, a half of my total shape is shaded. Adding fractions. Adding is also not too bad, but it's just not as easy as multiplication. But before we think of adding and subtracting, one really useful point when ordering, adding or subtracting fractions is you need to have a common denominator. So common denominator means the same number on the bottom, the denominator here. So if I took these fractions, I want them on a common denominator, I would look for their lowest common multiple, but it can be any multiple really, it's just easier to stick to smaller numbers. So I need a number that goes into 3 and goes into 5, so I know that that is 15. So I want to put them both on over 15, because 15 goes into both, and if I've done whatever I've done to the bottom, I need to do the same to the top. So from 3 to get to 15, I've times that by 5, so I have to times that one by 5. And here, I've times that one by 3, because 5 to get to 15, I've multiplied it by 3, so I have to do the same to the top as I do to the bottom. So they're the same fractions, but we've put them under the same common denominator, which is what we're going to need to do for adding and subtracting fractions or ordering fractions. So adding, let's take 2 fractions, 2/3 and 4/5, and the way to do this is you just need to put them under a common denominator and then add as you would normally add. A lot of the ways you'll probably be taught in school is I was taught a cross and a smile like this. So a cross and a smile, and wherever there's a line, you multiply. So cross here, 2 multiplied by 5 is 10. 4 multiplied over, you keep the plus in the middle, so that one there. 4 multiplied by 3 is 12, so that goes here. And then 3 multiplied by 5 is 15, that goes on the bottom. Cross and a smile. So adding, aka cross and a smile. And then you just, as if it was multiplication, you multiply through. This adding, you just add through. So 10 plus 12, 22 over 15. That is an improper fraction, so we could convert that to a mixed number if we wanted to, but it doesn't go in very nicely. Same with subtraction, same method, same cross and a smile. So all you need to remember for adding and subtraction is cross and a smile. So let's stick with the same numbers. 2/3 minus 4/5, but this time you keep the minus in the middle. It looks like hangman. Cross, smile, so 2 times 5, cross there. 4 times 3, 12, and then this times there. So this is kind of creating your common denominator here. 15, 15. So we're going to get 10 minus 12, which is minus 2 over 15. And that is how you add and subtract fractions.